Hello everyone, in today's session we're going to talk about another important and fundamental data structure called linked list. Stay tuned. In a single linked list, we can store a set of items in the memory discontinuously. In order to do that, we use a structure called node, and a node contains two parts. One part which keeps the data and another part which is a pointer to the next element of the list. And of course, there is a pointer to point to the first item of the list. For example, if the list is an empty list, it will be like this. And if it contains just one element, it will be like this, that the head points to the first item of the list and the next pointer for the first element is null. And if it contains two elements, it will be like this. And if you're wondering how we store the elements in the memory, we keep the item of the first element in the memory, and we can have access to those elements by using the pointer, which is data and next. And we can see the pointer to the next element needs, depending on the system and operating system, needs either 32 bits or 64 bits. In this example, we consider the case that it needs 32 bits in order to point out to the next element, and we can see in the address of 1100. The next element is stored and its pointer to the next element is null. In order to add one element in front of the list, we do as follows. Let's suppose that this is the list and this is the new item that we want to add in front of the list. What we have to do, first of all, we need to update the pointer of the new item to the first element. And then we should update the head pointer to point out to the new item. And then in this way, we can see that we added the new element in front of the list. And also this works if the list is an empty list. And in order to add an element after a given item like this, what we have to do is, first of all, we have to update the pointer of the new element in order to point out to the next element. And then we have to update the pointer of the previous item. And then in this way, we can see that we added the element between these two nodes. If we want to add a new element after one specific node, we need the address of that node. In this specific example, if we have the address of this node, we cannot add a node before that, and we need to scan all elements of the list in order to find the address of the previous item in order to be able to add the new item after that. This also works if we want to add a new item at the end of the list. What about deleting a node in front of the list? What we have to do is to update the head pointer to point out to the next item. And in this way, we can see that the node is removed in front of the list. But what we have to do to officially remove this node is to release the memory that is keeping this information. And then we can say that this node is removed. And if we want to remove a node after a given pointer, what we have to do, again, we have to update this pointer to point out to the next element. And then we can see that when we are scanning this list, this node will be ignored. But what we have to do is to release this node as well. And again, note that we need the address of the previous item in order to be able to remove one element. Otherwise, if we have the address of this item, we need to scan all elements from the beginning of the list and find out the address of the previous item, and then we can remove the target item. Regarding the time complexity, in order to insert or delete one specific element, if we are given the address of the previous item, we can do it in O of 1. But if we are given the address of one specific item and we want to delete it, or we want to add one item just in that position, we need O of n in order to do that, because we need to scan all elements and find the address of the previous item. Update needs O of 1 if we have the address of the element, and search needs O of n because we have to scan all elements from beginning till end of the list. As the merits of the single linked list, we can store some elements in the memory discontinuously. We can manage several similar or dissimilar items in the memory. Insertion and deletion operations are supported and the data structure is dynamic. But as the demerits, search is slow, it needs O of n. Access to one specific index is slow, and in other words, there is no random access support in this data structure. Given a pointer to a node, it takes O of n to delete that node or add a node in that position, and access to the previous item is not supported in the single linked list. And in order to solve the last two demerits of this data structure, we can use double linked list that we will talk about it in the next session. I hope you enjoyed. If you liked the video, please subscribe and share it with your friends. In the next session, we will be talking about doubly linked list, and see you there.